Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is 9,10-dihydroanathracene, which consists of two benzene rings flanking a central cyclohexane-like ring with two sp3ch2 groups at positions 9 and 10. Moving on to the next step. Treatment of 9,10-dihydroanathracene with acid, H+, and heat causes dehydrogenation aromatization. Under acidic conditions with heating, the central ring loses two hydrogen atoms to become fully aromatic, converting 9,10-dihydroanathracene into anthracene, A. Anthracene is the fully aromatic tricyclic compound. Moving on to the next step. Nitration of anthracene with HNO3 under heat. Anthracene undergoes electrophilic aromatic substitution preferentially at the 9 position, the meso position, which is the most electron-rich position in anthracene. However, under heating conditions with HNO3, nitration of anthracene occurs at the 9 position, giving 9-nitronathracene. And for the final step, 9-nitronathracene is a fully aromatic anthracene framework with an number 2 group at the 9 position, the central bridging carbon of the middle ring, which is aromatic in anthracene. Looking at option B, it shows the fully aromatic tricyclic system, anthracene, with number 2 at the outer position of the right aromatic ring, which corresponds to the 9 or 2 position substitution on anthracene. Option B depicts the number 2 group attached to an aromatic carbon at the outer terminal position of one of the end benzene rings, consistent with electrophilic nitration of anthracene at an activated position on the aromatic ring. Option A shows number 2 at a different ring position, angular, less favored. Option C shows number 2 on an sp3 carbon of a non-aromatic ring, but after step 1 the molecule is fully aromatic anthracene, there are no sp3 carbons. Option D also shows number 2 on an sp3 carbon with a partially aromatic structure, inconsistent with the fully aromatic anthracene formed in step 1. The starting dihydroanathracene aromatizes to anthracene under H plus delta, and anthracene undergoes electrophilic nitration with HNO3 delta to give the nitronathracene shown in option B. Therefore, the correct answer is B. Therefore, the correct answer is option B.